In this video, I'm going to prove that the function f, which maps integers to integers defined by f of n is equals to n squared, is not injective. Then I'll move on to the second part. I'll prove that the function which maps natural numbers to natural numbers defined by f of n equals to n squared is injective. So I'll start by looking at the first one there, the function which maps integers to integers. To prove that it is not injective, I'll start by looking at the definition of an injective function. A function f which maps a to b is injective if for all a, b in the set A, whenever f of a is equals to f of b, then a is equals to b. We want to check that whenever f of a is equals to f of b, then a is equals to b. So we are having our values there. Our a and b are integers. And what we want to check is whenever f of a is equals to f of b. But in this case, the function is defined by n squared there. So for our f of a, we substitute a into this equation, then we would have a squared. For f of b, we substitute b here, then we would have b squared. So this equation here, using this definition, will give us a squared is equals to b squared. We now go on and solve for a. In this case, we take square roots on both sides. And when you take square roots, we'll have that a is equals to the square root of b squared. And when we take those square roots, we know that it will give us a plus or minus b. So we'll have that a is equals to plus or minus b. So that is a is equals to b, or a is equals to minus b. And recall that we are looking at the set of integers there, the a and the b. So these two parts here, the a equals to b or a equals to minus b, they are valid. So what we are having there is we are having two values, a equals to b or a equals to minus b. But in our definition, we are saying that we should have a equals to b. So this condition here has been violated, and just because we are having that for all a, b, which are integers, whenever f of a is equals to f of b, we are having a equals to b or a equals to minus b, which violates the definition of an injective function there. So in this case, we conclude that that given function is not injective. I will now move on to the next one there, the function which maps natural numbers to natural numbers defined by f of n equals to n squared. In this case, I am going to use the definition again of the injective function. We say that if f is a function which maps a to b, that function is injective if for all a, b in the set A, whenever f of a is equals to f of b, then a is equals to b. So in this case, we are looking at the set of natural numbers there for our a. So whatever for all a, b, which are natural numbers, we want to check this condition here, which says whenever f of a is equals to f of b. So we are saying f of a equals to f of b. Using the definition here, what we'll be having there is for our f of a is a squared, our f of b will be b squared. So we'll be having a squared is equals to b squared. Then take square roots on both sides, so that we have a is equals to square root of b squared. And then we would have that our a is equals to b, or a is equals to minus b. But we are looking at the set of natural numbers here. Our a and b, they are natural numbers. Natural numbers are the counting numbers, the 1, 2, 3, and so on. So if a and b are natural numbers, but here we are saying a is equals to minus b. B is a positive number. When you multiply it by a negative, it becomes a negative. But it would then be saying that a is a negative number, which is not true in this case because we are saying a is a natural number. So this part here falls away. It's not valid when we are looking at natural numbers. So we remain with only one condition, that a is equals to b. So in this case, what we are having there is for all a, b, which are natural numbers, whenever f of a is equals to f of b, then a is equals to b, which is satisfying this condition here. So when you are looking at f, which maps natural numbers to natural numbers defined by f of n equals to n squared, that function there is injective.